Hello everyone. It is late tonight. I got work in the morning tomorrow, so apologies about that. 9:40 p.m. Sunday, June 29th. Now, I was gonna try to get my resume made this weekend, but it was a busy weekend. Went to go see my girlfriend. Spent time with my grandma. It was her 71st birthday, so we celebrated with that. And I had to do I did a volunteering event for my internship, so pushed me back a little bit. So I guess maybe tomorrow or Tuesday I'll look into making my resume. Probably need to do tomorrow because I don't know if any positions are gonna be opening up on the 1st of July. We'll see. That way you should get everything prepared. But enough yap. Let's start looking into it. So let's continue on with graphs. So yesterday we finished off with course schedule. So today we're going to go on course schedule 2. Let's see. I'm checking something real quick. Alright. Yeah, so looking up new graph positions are definitely opening up right now. So I need to go ahead and start applying to those. There are a total of courses you have to take from 0 to M courses. You are given an array of prerequisites. Get that you must take the course B. For example, return the ordering courses you take in order to finish a course. If there are many valid answers, return any of them. Wow. It is possible to return an empty array. Alright. Return any of them. Well, you know what? I think I'm going to actually go look at how he solved course schedule 1 as compared to how I solved it.
Hey everyone, welcome back. Let's write some more neat code today. So today let's look at a graph problem actually. It's called course schedule. We're given prerequisite was course 0. So therefore both of these courses are possible to complete, so we can return true. So let's look at an example where it's actually impossible. So we're given n equals 2. That means we have 2 courses, 0 and 1. Means so neither of the courses are possible. 3 to 4. So my goal here is for each of these nodes, I just want to know, right, for each of these classes, can we complete this course or not? And how do we know if a course can be completed? Well, just looking at this picture, it's obvious, right? 0 has a prerequisite of 2, but 2 does not have any prerequisites, which is great. It also has a prerequisite of 1, and 1 has 2 prerequisites, 3 and 4. 3 has 1 prerequisite of 4, and 4, luckily for us, does not have any prerequisites. So looking at this, it's kind of obvious that we can complete all these courses. So let's do the algorithm to be able to determine that. We see that these are kind of our base cases, right? 2 and 4 don't have any prerequisites. That's useful information, but we don't need a graph to tell us that. We can use a data structure called an adjacency list, and I'm going to call it prerequisite map, because the data structure I'm going to use is a hash map to represent this. So for each of our courses, we are going to have a list of all of its prerequisites. So for 0, we know 0 has 2 prerequisites, 1 and 2. And we're going to repeat that for every single course. So for 1, we know that 2 does not have any prerequisites, so we can just put an empty list over here. 4 also does not have any prerequisites, so we get another empty list. So now we're going to run depth first search on every single node. I'm going to do it in the order from 0 to n minus 1. So be starting at 0, so we're going to run depth first search on it, right? How are we going to do the depth first search? Well, we have our prerequisite map, so we're going to do it recursively. We see that it has 2 prerequisites, 1 and 2. So now let's run depth first search on the first neighbor 1. So now we look at 1, we see that it has 2 neighbors, 3 and 4. So let's recursively run depth first search on its first neighbor 3. So since 3 is a prerequisite of 1, now we want to know if we can complete course 3. So we look at its prerequisites. It only has 1, 4. So now we're going to check its only prerequisite 4. Can we complete course 4? And then we want to look at the prerequisites of course 4, which we know are empty. This is good, right? So now we see that this is empty. So what does that tell us? That tells us course 4 can be completed, which we basically already knew because course 4 has an empty prerequisite list. So I'm just going to put a little check mark here to say that we know course 4 can be completed. And so recursively, we're going to end up going back to our 3, and we see that it only had 1 prerequisite,
And we were able to complete that prerequisite 4, so therefore 3 is also a course that can be completed. And so what we can actually do is, from its prerequisite list, we see 4, we can just remove the 4. We know it can be completed, and so I'm representing that by having an empty list here, right? Just an empty list means that I know for sure that 1 can also...
Okay. So he did exactly what I did. Oh shit, topological sort. Dude, forgot about that. Oh crap, man. I gotta go back into doing that, man. Topo sort. That was some good stuff. Yeah. I remember that. I remember doing that in my algorithms class. I can't remember how I did it though, but I remember doing it. This one seems pretty hard. Okay. No. Oh. Sorry. There you go. Spell that right? Probably not. I think this requires a topological sort. I'm not gonna lie. Yeah, I'm not gonna lie, I don't remember how to do top low sort. It's been about a year since I've done top low sort. Actually, been over a year since I've done top low sort. Last time I did it was March 2024. Yeah, I don't remember how to do it. It's crazy. It's been a year. Jeez. This past year, I've just been stuck in project hell, and it's been good because developmentally, I'm a lot better than I was. But man, I kind of forgot everything. I mean, a lot of lost time, I guess. I guess yeah, it's standard. It's a problem as a graph where courses represent the nodes. Yes. Yeah, okay, so that's what I thought. Alright, I gotta look up how to do topo sort. Topological sort. I bet I got my algorithms book somewhere around in my room, and I wrote down how to do topo sort in that book. If I can find it, I might be able to, because my professor explained it way better in these websites. Hold on. Okay. I'm dusting off the old algorithms book. Let's see, when did we... It was greedy... Knapsack... okay, here we go, we got some graphs here. Step for search... Corrected... DFS... Wow, no! Split the page, no. No! Cut vertex. Oh, I remember this. Wait, hold up. I missed these classes, I'm not gonna lie. These math classes, there's a lot of theory. Everything just felt so concrete. I loved it. Okay, here you go. Directed graphs. We're starting to get closer. graphs here. Dumb board. Extras. Okay. I think I'm thinking of a component graph. I don't think I'm properly thinking of a top-load sorting. Top-load sort is where everything is pointing the right way, right? Right. What? Okay. Really? Is that simple? Okay. Yeah. So that gives me one variation, but the 5 and 4 can be swapped. That's why I have to get all variations. Oh my days, I hate this problem. I mean, I get it, but like. I kind of want to give up. I want to throw my towel in, but yeah, let's do something today. overturn any of them, not all of them. Ah, they're. Oh, yeah. I like the word neighbor. Interesting. Okay. I'm totally not understanding this, so that was kind of a cheat. But, you know, we do what we gotta do out here. Okay, sorry. Just had to read that for a second. Yeah, I'm gonna call it here because I gotta go to bed. My bedtime. Thank you for watching, and yeah, I'll see you tomorrow.